In fact, Dr. Negi Saab invited for history of the pipeline. Earlier used to give the topic to me, the supply chain management, integrity management, construction challenges and all. Possibly he is thinking that we are slowly moving into the history of the pipeline generation in India. So it's apt topic which is given to me as a history of the pipeline. So I'll be briefly touching about the brief history of the pipelines in India and certain advantages and other thing. Pipeline community is set here, so may not be required that much, and development phase. Then I'll be switching over as directed by my senior Dr. Regi, that I should talk about the Indian Oil's contribution in the pipeline's role and the journey I'll be talking. Failure has always been a constant source of learning in any engineering industry. So I'll be touching upon that, and for the road ahead, this will be briefly touching about. As it is indicated that pipeline is not a new system, even the 4000 BC also the pipelines in the form of a drainage and water pipeline and systems were existing. Of course, not today's like efficient pipeline system. Chinese used some bamboo pipeline for gas. At that time, the gas wells were not there. Gas was not drilled. Certain seepages of the gas were taking at the surface level, and people wanted to divert for the burning the gas for the lighting purpose basically. And Chinese were one of the premier in that whole 400 BC. They used the bamboo pipe. For, of course, a small diameter bamboo pipe for that. And more than 10,000 years back, Romans and others, they have used. I'm not going much about that history because things have happened, and then the cast iron pipe has emerged in 18th century, which for water line, sewer line and gas pipeline. Steel pipeline emerged in 19th century. That has changed the life, and strength of the pipeline and all sizes were available, and it is increased. 1879 is the remarkable year when the discovery of the oil took place in Pennsylvania, and first long distance pipeline, then long distance pipeline, 109-mile pipelines of 6-inch diameter, and subsequently couple of years later 87-mile line pipeline was done in Buffalo in USA. It is not only USA, but parallelly development were taking place in Russia also. Parallel development were taking place in the northern Europe also in the terms of the pipeline community. But when we made the pipeline, high strength pipeline, that has really been changed. And electric arc welding in 1920, when joining the section, otherwise it used to be the screw-based system, a low pressure system, and that has really changed the pipeline scenario. We have gone for high pressure, large diameter, leak-proof joint. In 50s and 70s, there was a major contribution in the pipeline from ductile iron, concrete pipe, water pipeline, PVC pipeline we created for transportation of various type of commodity, not only the petroleum product. We also started the application of the PIG, that is a pipeline inspection gauge, for the cleaning of internals of the pipelines, because in the process of the pipeline transport of the fluid, the muck gets accumulated, be it is a liquid pipelines or be it is a gas pipeline also, certain amount of moisture if it is there, or black powder formation is there, and that type of a removal, the PIG is still required. We started an era of a batching of a petroleum product through a common pipeline, because the pipelines in a particularly gas is a uniform commodity, but commodity or crude oil is also largely a uniform, but of course we have a variant within for the refineries. But in case of a petroleum product, multiple products we are carrying historically from the same pipeline system, and the different type of batch philosophy we introduce, and cathodic protection, because unless you take some precaution for the pipeline, it is a hostile environment of the soil is going to affect the pipeline. And the construction also in 1950s, the large side booms and other things which can support the pipeline for constructing, making a ditch and supporting the pipeline, then welding a section above ground, and so that you can lower a larger section within that ditch. So these booms were helpful to you. And machine drilling and boring of major crossing. At the time, the SDD and other things were not there in 1950s. So the boring has started, so we will be able to cross the road or a small river with the help of bore. Then bending the line pipe, because when you are laying a pipeline, it is not only a straight line you are going from a TP to TP or something like that. You are aligning the pipeline, bending the pipeline as per the curvature of the ditch. So the bending machine, when the field bending started, that was a major breakthrough in the case of a pipeline. And X-ray to detect the welding flaws. In 1950 itself it was covered, and at that time different type of radiographic problems were solved about the quality of the weld, because once the quality of the weld is good, then only you can rely for the high pressure system of the pipeline. 1970 further has seen the horizontal direction drilling. The well, by that time, the vertical drilling for the uh, oil well was very, very common. At that time, it was started from oil well scenario only, the horizontal direction, because the oil is not possible to get. They were able to divert the tool in a different direction. So similarly, from there, the horizontal directional image, and largely we are using. Initially, it used to limit a small line, but if you remember that last year in the 2024 only, a very large Brahmaputra crossing of two pipelines. One is the northeast gas pipeline, as well as the one crude oil pipeline, which is originating from Paradeep, taking the crude oil through SBM system of Indian Oil Corporation and transporting to the Nuwaligarh refinery, which has been expanded from 3 million ton to 9 million ton. That pipeline has laid, and the crossing was over more than 4 kilometers. That was really a challenge. A Brahmaputra river crossing over 4 kilometers, and that was successfully done in case of SDD. Integrity, Mr. Bosbabu has talked much detail about that, so I'll not be able to touch detail about that, but in 1970s, the concept of integrity started, so it is not a new topic. More than 50 years of methods change, philosophies change, pressures change, but the integrity has evolved over the period of time. Similarly, not only the pipeline material or grade or compressors or pumps we are changing, we have parallelly changed the communication system. Oja, my senior is sitting here. When we started the carrier, possibly 100-watt HF set was the only means of communication available to us across the cross country, because certain band was allotted to us, and 700, 800 and 1000 kilometers pipelines we were operating with the help of the HF set only. Gradually, we have gone for the micro station, satellite control of pipeline, SCADA system of the pipeline, and of course the slurry pipelines also elsewhere came because of the ore found in the country. Apart from when we talk of the pipeline material, it is not only the pipeline material, the coating, because the pipeline coating is very, very vital, because the first primary barrier is the pipeline coating. The coating also evolved. Of course, I am not talking of a very history of the coating, but it is a earlier part, the animal fats and other things were used as a layer of the coating in the wooden system and other pipeline system. And basically, 1920 onwards, we have seen the coal tar animal coating, and going to the various phases in Indian Oil Corporation. Of course, the first India 3LP pipeline, of course, I must salute and appreciate that the 3LP pipeline coating was the HBJ gas pipeline, which started in 1984. That was a game changer for the industry. Now, most of the pipeliners prefer for the 3LP pipeline. Indian Oil Corporation has gone for the 3LP pipeline way back in 1995, when we constructed Kandla-Bhatinda product pipeline, country's then largest product pipeline, about 1300 kilometers. And progressively, we have gone for that FB, dual FB, and certain areas, other type of coatings we have also gone. Particularly in era around 2005 to 2010, we have gone for the FB pipeline. We constructed some of the pipelines like Sonipat to Meerut, Roorkee, Najibabad, Mathura to Bharatpur. These pipelines emerged during that period where we have gone to FB, but now lastly, we go for a 3LP pipeline, which is more robust and suitable both for the normal ditch as well as your SDD pulling. This line is suitable, and we go for that. I am not taking much time on this slide because everything is low in the third column of pipeline. Environment is talked much about the pipeline. Definitely, pipeline is most suitable. And why it is suitable? I will just recall the incident last month which has happened. One LPG tanker on a Jaipur road has claimed more than 30 lives. This is called a safety of pipeline transportation, because alternate modes have their importance, no doubt, but the pipeline is really very, very safe. Definitely a 30 plus precious life we are losing from 10 or 12 ton of LPG. Imagine a pipeline which is transporting a huge amount of LPG every time, and which is reaching to your doorstep. So the pipeline is definitely safe compared to other modes. Development of now oil and gas pipeline core area. We talked about the Assam Nahar Katia to Baroni pipeline. May I simply remind, the Digboi refinery came in 1901. I mean, when the world was discovering the crude oil, simultaneously around the same time, oil was discovered in the Assam Digboi. We constructed a Digboi refinery, which is still operated. Indian Oil is operating 11 refineries in the country. One of them is the Digboi refinery. 1956, 75-kilometer twin pipeline, one for the white product, one for the black product, was laid from Digboi to Tinsukia. We have used for a considerable period of time, but it was not able to meet the OISD requirement and other things, and gradually the condition worsened, and around 2015 or 16 we have decommissioned, but it has served the nation for over 50 years before the decommissioning. Yes, 1962, Assam was having a crude oil, where the other places were having a deficient resources of the crude oil. Upper Assam, the crude oil pipeline from Naharkatia to Barauni for feeding the Barauni refinery, which came under the second 5-year plan of the Government of India for the development. The line was connected. It was 1167-kilometer long pipeline. This pipeline is still operational, but not from Assam we are getting the crude, because Assam has around 4.5 million ton of the crude, and it has 4 refineries, which was not sufficient to meet the crude oil requirement of even Assam-based refineries itself. So we started importing the crude at Paradeep, and through this product, Indian Oil is transporting from Barauni to the refineries located in Assam. Pipeline still continues the same, and still one of the oldest crude oil pipeline in the country. 1964, we commissioned the first product pipeline, Guwahati-Siliguri, 435-kilometer pipeline, 8-inch pipeline. Still we are using, and still there is a case study, about 2 slides I'll be covering little later. 66, we completed next Koyali Ahmedabad. Sir was talking about Barauni-Kanpur pipeline. Same year we also completed Barauni to Kanpur pipeline, because Barauni refinery was operational way back in 1965. And 1967, Haldia-Barauni crude oil pipeline, because Haldia refinery at the coast of the eastern coast has come, and we connected both refineries through the pipeline system. And 1978, first single point mooring system commission, because that has changed the game, because crude oil, earlier the crude oil we are getting from Bombay High or some other place, or the Gandhar crude, or maybe South Gujarat crude, but the quantity was very less, and countries the consumption was picking up, particularly after 1970s, and when the development has picked up. So we wanted the crude oil to be imported in a bulk. For importing the bulk, India has a vast coastline, about 7,600 kilometers, but somehow, if you look at the bathymetry chart of the India coastal line, the water near to the Indian coast is very less. It is a shallow water. We don't get a chance that we can bring a large tanker there. So we had to go to the sea, inside the sea, to get the larger tanker, that is VLCC, very large crude carrier. And prior to that, about 50,000 ton maximum we are getting that. With the VLCC, we are getting 320,000 ton, because the economy of scale was there, and first SPM was considered. Here I would like to highlight one thing about the beauty of public sector and the government organization. Way back in 1978, when first SPM was commissioned, at that time the approval process was through the Planning Commission of the Government of India. 1974, the Planning Commission, the report was sent for approval, and 1978, we finally commissioned. In between, certain approvals and construction methodologies were adopted. It was done in Gulf of Kutch. Country has today, that was the first SPM system. Country has about 20 SPMs, 27 SPM system as of now. Out of 27, 13 are in Gulf of Kutch. Means you can understand as a selection made by a public sector, how important the location was where the 13 SPMs are now operational in the same Gulf of Kutch, because it was a facilitating with the natural sea channel, and that has helped a lot. So this is something like that. Normally, public sectors are considered little myopic in the decision, but that talks about the foresightedness of the people who selected the location. Moving to that, 1978, with this linked with the SPM system, Salaya-Mathura crude oil pipeline came, because the Mathura refinery was going to be operational and Gujarat refinery was under expansion. And then from Mathura refinery, we product Jalandhar pipeline, Mathura Jalandhar pipeline came, and parallelly we started Mumbai Pune Solapur product pipeline, where the consultancy was provided by Indian Oil Corporation way back in 1985. 87, as we talked about, the HBJ pipeline started in 1984 and commissioned in 87. Jamnagar Loni sir has talked about that, such a long pipeline within a very short period of time, that is a record. And 21st century witnessed unprecedented growth in oil, gas, natural gas, LPG and CGD setup. 2015, first heated crude oil pipeline, that was the world's largest heated crude oil pipeline of not our Indian Oil Corporation, but the Kane Energies. It was 600-kilometer pipeline, where the heat from a crude line, because this pipeline, this type of a crude, the wax appearing temperature itself is 56 degrees centigrade, means the pipeline has always to be remain heated more than 56 degrees centigrade. And they were to deliver the crude to Indian Oil for our Gujarat refinery processing and Mathura refinery processing, and they connected to Gujarat, our two locations, by laying a 600-kilometer long pipeline from Kane Energy field. Today, coming to era that everybody has talked about, the 60,000 kilometers of the pipeline we are going to have. Another 30,000 kilometers, if you see the STPs and other things, they are under construction. Here I will be getting more details about that, because under construction around 20,000, non-piggable 30,000 like ONGC pipelines and all, and the sub-transmission pipelines of the CGD sector around 25,000. So this is something, if country is going to have couple of years later to the extent of about 135,000 kilometers of the pipeline, means from today's quantity is likely to be doubled in the couple of the period of time. What are the growth driver in the country? Any industry grows because certain growth driver there. Natural gas share in the primary energy 6.2 to 15. Supposed to be a very, very ambitious and difficult target, but all the things are moving in that direction, because when you burn the methane, there is a 1 carbon, compared to when you burn the petrol, there are 7 or 8 carbon. When you burn the diesel, there are 10 carbon molecules in that. So these things, definitely methane gets an advantage, natural gas gets an advantage. That's why it is increasing the natural gas share becomes a very, very vital for that. Increasing penetration of LPG pipeline, particularly after Pradhan Mantri PMUI, Ujjwala Yojana, it has increased. We have about 14 crore LPG consumer in the country, and LPG become available to everyone. Not earlier used to be a long list of LPG waiting and all, so that has been reduced. So that's driven the growth of the LPG pipeline beyond Jamnagar Loni also, because we constructed the pipeline in the eastern sector from Paradip to Barauni to other places, and including the world's largest pipeline, what Dr. Negi has touched about, the Kandla Gorakhpur. Dedicated ATF pipeline, because the consumption of ATF in the country was increasing. It was necessary for maintaining a quality and consistency of the requirement of ATF. The pipeline construction, the ATF pipelines, Indian Oil is also having a couple of the ATF pipeline already constructed, and some are under consideration and construction. Then large-scale CGD network, we already know. Increasing share of coal bed methane. India has few coal bed methane pipeline, because it's another source of a methane. India, we know already, 4th largest coal reserve we are having. So there is a possibility of coal bed methane is very, very high. But since the coal quality is challenging, Government of India has spent some money on the coal gasification also, where the moisture content and ash content, which are the main problems of the coal, that can be removed through the process of gasification, and then it can be transported. Then transportation of the blended fuel. Indian Oil became the first one to transport 10% blended ethanol blended petrol through the pipeline system, multi-product pipeline system. We first transported from a small section of Mathura to Agra, and then of course it's going for a long time. And another growth driver is carbon capturing and transportation and storage, because Planning Commission data indicated we are not only the 3rd largest consumer of energy, we are 3rd largest emitter also. Owing to our large population, per capita emission is less, but we generate carbon emission to the extent of 2.6 gigaton per annum, which is one of the very, very high figure. And unless the source carbon capturing from the power plant and or something, petrochemical or refineries are not taken, and this thing going to be a challenge. In fact, Indian oil refineries and some other refineries have signed the MOU for capturing the carbon from the dioxide from the source and transporting for the EOR, but so far it could not materialize, maybe the cost constant. Future I am seeing it's a bright for that also, carbon transportation and capturing and all. Of course, in my later part of my job, I was involved in the carbon dioxide pipeline too. Hydrogen pipeline, if either hydrogen or ammonia, because if you go for a hydrogen or a derivative pipeline, ethane pipeline is already operational in the country. Ethanol pipeline, I am anticipating, because country's MS requirement is about 37 million ton. 20% of that means more than 7 million ton ethanol requirement of the country will be there. That is about 3 years requirement of Nepal. Something like that, you require a pipeline to transport, because you'll not be able to handle the requirement alone through the tankers and other things. So maybe tomorrow you'll be going for a dedicated ethanol distributory pipelines to the refineries for mixing it to MS. And as on today, another important aspect, in our country, we are transporting only 56% of the petroleum product to the pipeline, compared to the world average of more than 75%. So definitely there is a scope of further increasing the transportation through the pipeline system. Why there is a concern? There is some concern that full pipelines are not fully utilized or something like that, but at the same time, still we are transporting 56%. That is a cause. Of course, crude oil, earlier we are transported about 1% crude oil from Barauni through by railway to Guwahati and Bongaigaon for a couple of years, because the pipeline was saturated and all India pipelines were going for a rehabilitation work. And now, of course, we are 100% crude oil is met through the pipeline system, and so is nearly the gas, except the virtual CGD setup where they bring it LNG and put it. Pipeline industry came much earlier, and a regulator, of course, PESO was there right from the beginning. To salute to Srivastava Saab. Sitting here, PESO was there from the beginning, provider guidance to the pipeline industry, but other regulators like OISD and PNGRB came later, but their presence was felt. Each one has contributed very, very effectively in the development of pipeline. Petroleum rules under the Petroleum Act 1934, the petroleum rules were framed, and petroleum rules were treating with the right of way, design, route, laying, selection, protection, hydro test, operation and maintenance, patrolling, all these aspects were guided by petroleum rules. So industry was largely driven by petroleum rules at that time. Of course, the code and standard, we are going for API code, SME code and other DNV codes, but so far the general rules of the country is concerned, it was all enforced through the single authority, that PESO. Then the contribution of the PNG, RB and OISD came into the picture. Regulatory regime have contributed very, very effectively, particularly PNG, RB within 15 years for the distribution of gas network. They allotted entire country, as Sir has pointed out, except the Lakshadweep, Andaman and maybe some other area. Rest of the country has been awarded for the GAs. And not only that GA award, they developed the code standard, developed the safety protocol, developed the integrity protocol, developed the safe emergency handling protocol like IMS, T4S and ERDMP regulation. An authorization body it became for the downstream sector. And gas exchange incorporation, that has been a game changer. Possibly we'll be able to trade the gas in a better way, with an efficient way, so that a fair price available to the purchaser. OISD has done a basic work of design code for gas pipeline, oil pipeline, LPG pipeline, safety system, safety protocol in a big way, integrity guidelines, code for various systems, SCADA system, safe working, electrical system, M&I of pipeline, offshore and onshore pipeline, and associated facilities. They were largely driven by OISD code, and PESO has rightly thought of the certain OSD code, because OSD was, most of the codes were voluntary in nature for the industry. So PESO has made a part of several 7 codes, which has become have now legislative backing, and everyone is required to use that. So this is the PESO has taken a proactively approach in that. Now coming to something about Indian Oil Corporation. I'll, sir, try to finish as early as possible. I'll not take much time, sir. So, design and engineering and transportation of the pipeline. As on today, IOC Pipelines is the largest pipeline operator in India. Over 20,000 kilometers of the pipeline is being operated of various, like crude oil, petroleum product, LPG, natural gas, ATF, heated crude oil lubricating pipeline. We recently a small pipeline for in a lubricating oil blending area, and low temperature pipeline also in Gujarat. We have done a small pipeline, but we also constructed successfully. And readiness of the hydrogen transportation is being examined through the consultant route, that what should be the blending ratio and what. Because when we talk of a hydrogen blending, it is not the embrittlement we are concerned about that. Because we have also see the effect of the hydrogen on the elastomers. Because you have a meters, you have a walls, you have a soft elastomers and all those things. What is the impact of hydrogen on this? This in totality we have to study. Besides the pipeline, Indian Oil Corporation Pipelines has been instrumental in designing the tankages, crude oil, petroleum product, mounted bullage, O&M of SPM system, and training and upskilling of the force, particularly in a difficult areas like SPM monitoring, because first SPM as a owner, we have subsequently trained almost all the SPM owner in the country. We have provided the training for O&M to those companies, including private sector, including the public sector. Many first for largest pipeline operator by Indian Oil Corporation. First to design own pipeline. Mathura Jalandhar, Salaya Mathura pipeline was, and Mathura Jalandhar was designed by Indian Oil Corporation. First time inline inspection, which was most of the places was unheard. 1987 we have gone for the HBK inline inspection. First commissioning of SPM I talked to you about 1978. First development of inspection tool. Indian Oil is only public sector organization which is having a capability of among the pipeline operator to have their own tool. First introduction of a drag reducer additive for flow improvement in a pipeline way back in 1990. First time hot tapping to replace a pipeline section. In fact, incidentally, when HBJ was getting constructed, it accidentally had hit the Barauni-Kanpur pipeline. It was a big dent in the Barauni-Kanpur pipeline, and since Barauni-Kanpur pipeline was meeting almost half the UP's requirement and plus the entire Nepal requirement, shutdown taking was a difficult, so we have gone for the hot tapping system after taking the approval from PESO in that case, and we have gone for the first time the hot tapping, through hot tapping the replacement of the pipeline section, and we have trained the officers for carrying out this job in future. First started in PMC services for pipeline for HPCL way back in 1983. First to build and commission transnational pipeline to Nepal, and first introduction of corrosion inhibitor in petroleum product pipeline way back in 1988, and first introduction of CI in crude oil pipeline, because earlier country was using Bombay High crude oil, which was very waxy in the nature. It was making an internal wax layer in the pipeline and preventing the high corrosive metal to reach to the substrate of the material in the pipeline. But later on, now Bombay High contribution is in fact less than 10% of the Mathura refinery and Gujarat refinery. So now aggressive crude of high sulfur bearing crude and other crude came, then definitely the requirement of the corrosion inhibitor also came. LPG pipeline, we learned the big lesson. We didn't use the corrosion inhibitor for first 6 years of this operation, but later on we learned it is getting corroded in first inline inspection, and we have started using. First CI development we have done in the country. First DRA, Indian Oil Corporation, with the help of one private company joint venture, we are selling the DRA, which we had been importing from America for a very, very long period, more than 30 years. And first ethanol blended MS we have pumped through pipeline system, and first benchmark study of the pipeline through your external consultant we have carried out. That was the role of the Indian Oil Corporation. I am summarizing the journey of 6 decades in this slide. Emergence of first decade, if you see 64 to 75, it was the BKPL, GSPL, HMRB. My ex-boss, Mr. Thakur, is sitting here. We were together in the Barauni-Kanpur pipeline. At that time, the LFERW technology was there. No SCADA system, 100 watt HF set was being monitored. Next decade, we have gone for design and project monitoring. Indian Oil Corporation has commissioned first SPM, Salaya Mitra, MJPL were designed themselves. SCADA was introduced, digital microwave we abrogated. In the further next decade of 86 to 95, we have carried out the inline inspection, DRA introduction, hot tapping in the pipeline, OFC cable, Kandla KBPL designed through PMC. We learned a lot of things again from PMC, though we had prior to that designing our pipeline. Branch pipeline we started. First OFC cable was laid in the Kandla Bhatinda, and few pipeline additions we made, and the growth continues in 95 to 2000, where the southern India we had a presence. Eastern region expansion took place. Second SPM system in eastern coast, that is SPM, Paradeep has come. Change of the service of the line we have introduced for the first time, crude service to product service to crude oil service. These things have taken place with the approval of PESO and by in-house competency only, and technological other intervention takes place. Next decade, the 2005, 6 to 15, we have upon the growth, we entered the gas because Indian Oil is also operating the gas pipeline. We entered the LPG pipeline. We also entered in the alternate energy area of wind energy, solar energy, inline inspection, our own tool, PIDWS, that pipeline warning pipeline intrusion detection and warning system, PMC services in a large scale we started, and similarly, Sir was indicating about the largest LPG pipeline in India. The PMC was provided by Indian Oil Corporation. And then next decade, which is going on at present, not only the PMC growth, remarkable growth, change in the metallurgy we have gone for certain area because of the aggressive type of a crude we are handling, transnational pipeline, CO2 and S2 we are start examining now, biofuel blend, ethanol blend, heated pipeline, and we had been a technology provider, automation, database, centralized integrity management system. Of course, we are under the first one. Earlier it was done by other operators. GIS, drone-based surveillance, these things started and journey will continue for the days to come. Few initiatives beyond that we have taken e-operation. There is no system of any logbook writing which has been a part of the pipeline system since inception. Implementation of a centralized integrity management. AI we have used for the first time in the LPG pipeline as a pilot case, and we are scaling up because the AI application means you come to know about so many other aspects, what is happening in the pump, and much before any failure takes place, anyone can continuously monitor, not necessarily the control room people sitting in a globe, next area of the globe, they can monitor and all those things. Pipeline scheduler we introduced, PMC for the largest LPG pipeline I just talked about. Pilot study, hydrogen is going on, and we had a AC failure, and after that, of course, the software modeling is being carried out and large-scale training and certification of the pipeliner because the man machine behind the machine is very, very vital. Challenges are there because 30% pipeline, if you see, are more than 50 years old. So limited data, old equipment not compatible with the latest SCADA servers. LFERW pipeline, several failures we have already experienced, no optical fiber cable, encroachment in the right-of-way, old coating requires a large-scale refurbishment, regulatory compliance becomes difficult, case crossing, suspended crossing, railway bridge crossing has been a part of the system. These challenges I am skipping because all pipeliners knows what are the challenges, but some of the photographs will speak about what are the real challenges. These are the real pictures of the pipelines which is failures in India. Every challenge, every failure gives a learning. Accelerated corrosion due to AC interference. Salaya Mathura pipeline in Jamnagar failed. Soon after, the Sir was the, I think, CCOE just after that. And definitely due to AC corrosion was the main reason, and we learned in a hard way, and then we taken a proactive approach. LFERW seam failure has been a recurrent phenomena, and Progressively, we have replaced the system, or partly we have gone for the total system rehabilitation. Longitudinal crack in the double submerged arc welded pipeline we have found due to change of services, and one of the new pipeline we are constructing, and of course we are going for alternate utilization of that pipeline. Flange gasket failures in 15, flange failure in T point after 15 years of service. This was the, after investigation we work out to be, it is a fatigue failure. And flange gasket failure in above ground section. These have high consequences. I have written in one line only. Dent in submarine section of the 48-inch diameter pipeline. Buckle in crude oil pipeline. Just previous side, last corner, if you see, the buckle is there. So this has actually happened. Snapping of the SDD, Mr. Bose Babu talked about. Luckily, in that same river, we are also having a pipeline. Couple of months back, I mean about a year back of this incident, it was brought to my knowledge, I was the regional head there, that our pipeline is crossing the river, but it is coming out at a location which is still in the floodplain of the river, and we took a proactively approach of doing re-SDD and alignment of the pipeline so that our pipeline could be saved. All 4 pipelines were snapped during that process, and of course OISD put a penalty on of us and including on us also, Indian Oil also. Failure of interconnection is a stagnant section because one line to another we connect, certain section remains not continuously working, and failure has taken place. Through that we learned. Then we started the LRUT concept that we should go for a non-usable section, non-piggable section, LRUT concept, and theft by making underground tunnel. Normally petroleum products, people were digging, and some telltale sign was there. First time I was the DGM of Bombay, Delhi area, and there the tunnel was made, and it was very difficult to no activity outside, but we are, through our system, we are finding out some leakage and some pilferage is taking place, and it was difficult, and somehow through our own inline system, inline inspection system, we could work it out. It was a tunnel, and of course later on there are many theft through the tunnel system in the pipeline. These are the future growth, you already know that. One case study, just I'll be completing one more slide, sir. One case study I'd like to make, the Guwahati-Siliguri pipeline, for the benefit of Mr. Raj Kishore who is sitting here. 5L grade B pipeline, not X65 or X70 pipelines. 5L grade B pipeline, LFERW pipeline, way back in 1964 we commissioned. Petroleum Product Service, coal tar enamel, 81.2 kg MOP, of course, ICCP protection is there, and suspended river bridge crossing and all type of crossings were there. No corrosion indicator was used till 90. First MFL was done in 90. It has indicated some defects and we have rectified. Subsequent MFL based inline inspection indicated larger defect. Then we have started attending this pipeline. This pipeline incidentally routine maintenance like CP and other things is done by Oil India Limited, so we are getting off readings only once a year, or of course in our Indian Oil pipeline system on and off CP potential we get every quarterly. In this case we are getting once a year. Then we took a large scale coating rehabilitation. Current consumption has reduced, and latest inline inspection was done in 2019, and based on that we have gone for all. Prior to that only, Mr. Ojaji was also the head of the Eastern region looking after this pipeline for some time, and all the suspension bridges progressively were converted into the SDD and defects were rectified, and with this system we are operating the pipeline as on today with MOP, that is 81.2 kg per centimeter square. Incidentally, I made this presentation, of course it's a brief presentation, detailed technical presentation I made way back in 2018 to POF, that is Pipeline Operators Forum in Europe, in France, who guided the inline inspection specification. They said, no, you don't run at MOP, you stop it or you reduce it immediately or something like that. But because of the health we can maintain, I wanted to communicate through this slide only. If you are able to maintain the system, you can survive till eternity, though the code as per OSD 141 allows you 25 years of service. It is something like that. Some attention is required. In a family, you have a grandparents, you have a grandchild also in between the middle generation. So similarly, a different type of a philosophy is required for attending that. And if we are able to attend carefully, we can run perpetually the pipeline. I have a case example of China where they are running a more than 100-year pipeline. So these things are continuous. It is the something. Next era is going to see the emerging trend of technology base, and I'm sure rules and regulations are forming, drone system, UTCD tool, and fast emerging various satellite technology, AI, ML will have a larger share in the market for doing that. And progressively, I'm thinking that non-metallic pipeline will also emerge, but will be totally dispensed with the corrosion aspect, provided it becomes cheaper, provided it becomes cost-effective for laying and maintenance purpose. Thank you very much. Thanks for your kind attention.